हेलो स्टूडेंट्स, आज जो हम डेफिनेशन करेंगे काफ़ी इम्पोर्टेंट डेफिनेशन है और वो है कोशी सीक्वेंस की। कोशी सीक्वेंस की 3 डेफिनेशन हम करेंगे। मतलब वी कैन राइट कोशी सीक्वेंस इन 3 डिफरेंट वेज। सो हालांकि इनमें कोई डिफरेंस नहीं है, दिस इज दैट विल बी सेम फॉर ऑल, but we can write it in 3 different ways. So I'm first of all I'm writing the basic definition of Cauchy sequence. A sequence xn is said to be Cauchy sequence if for each given epsilon greater than 0 there exists a natural number n such that xn minus xm is less than epsilon for all n comma m greater than equal to capital M. We have already discussed the convergence of sequence, and we have discussed its we have visualized this the definition of convergent sequence, and we will also try to visualize what is the meaning of this definition, so you will have a better idea. This mathematical expression, the better idea of this mathematical expression. So let us write. Suppose this is some sequence xn whose first term is x1, x2, x3 and so on real line, x4 and x5 and so on. After certain stage, suppose we have an xn element, and after that all the terms of sequence will lie in a width of epsilon only, right? So the difference of two terms of sequence is always less than epsilon, right, for all the terms which comes after xn, right? For n m greater than equal to n, capital N, xn minus xm is less than epsilon. Means, suppose this is the width epsilon, so all the terms comes after this xn will lie here, all the terms of the sequence. Now how many terms will be there in this width, in this band? Can you guess how many terms will lie in this? Because we are talking about all, for all n m greater than equal to n, this n is fixed. इसके बाद वाली जितनी भी सीक्वेंस की टर्म्स आएंगी that will lie in this bandwidth epsilon. So there will be infinite terms, there will be infinite terms, and that infinite terms, all infinite terms will lie in this band, right? Such that if I take any two terms xn and xm, right, suppose this is if I take it as some, suppose this is xn and this term is xm, then this difference will be less than epsilon, because epsilon is that much distance and this distance is small. So all the terms will lie in this epsilon, right? So this is just to visualize you, to make you understand what is the meaning of this statement. So the statement is, after some stage all the terms of the sequence will be close to each other. एक स्टेज के बाद सीक्वेंस की जितनी भी टर्म्स होंगी, उसके बाद वाली जितनी भी टर्म्स होंगी, वो सारी क्लोज होंगी, सबका डिफरेंस, कोई भी दो टर्म्स का डिफरेंस जो है वो लेस देन एप्सिलॉन रहेगा, राइट। सो ये n किसके ऊपर डिपेंड करेगा, दैट विल डिपेंड ऑन एप्सिलॉन ओनली। जैसा एप्सिलॉन होगा, अगर बड़ा एप्सिलॉन होगा तो स्टेज जल्दी आ सकती है, अगर एप्सिलॉन छोटा होगा, बहुत छोटा होगा, तो हो सकता है वो स्टेज थोड़ी देर बाद आए, राइट। सो दिस इज द होल कंसेप्ट. So this is the first statement. Now I will write the second one. Second one is just a particular case of this statement. So the second statement is a sequence xn is said to be a Cauchy sequence if for each given epsilon greater than 0 there exists a natural number m such that xn minus xm is less than epsilon for all n greater than equal to 10. So if you want to make it more clear, then I can replace this small m by capital M, capital N. Then you can see, then it will be just a particular case when we take m equals to n. So this is a particular case. If I fixed one stage, that one element as xn, another element as any other element, right? So xn minus x capital N is less than epsilon for all n greater than equal to capital N. So this is just a particular case. So it resembles with the what is the importance of this statement? Actually, it resembles with the definition of convergent sequence. In convergent sequence, we also take some stage, and after that all xn that converges to L. Xn minus L is less than epsilon for all n greater than equal to n. So this definition, second statement, is has special importance when we use the definition of convergent. So whenever there will be a convergent case and we want to use the Cauchy sequence, or we have given a Cauchy sequence and we want to prove some convergent sequence, then we will use this definition. So it has because this statement has some resemblance, some likeness with the definition of convergent sequence. So let us move to the third statement. So third statement is, it is again the same statement which is second, and I will write it in some other form. A sequence xn is said to be Cauchy sequence if for each epsilon greater than 0, given epsilon greater than 0, there exists a natural number n such that xn plus k minus xn is less than epsilon for all n greater than equal to capital N, k equals to 0, 1, 2 and so on. So this is again the same definition. Now the meaning is same. Now see, how can we say that the meaning is same? If again I visualize this definition, so these are two terms which come after n, this stage. So there is a certain stage, after that the difference between any two terms will be less than epsilon. So So there is a stage. So again, x1, x2, some are close, some are far, right? And after some certain stage, when xn will come, all the terms will lie in the this epsilon. So now I have taken two terms of the sequence. What are these terms? These are n, where n is any natural number greater than this. So this will surely, xn will surely come up here, because it will come after this xn. And secondly, second term is n plus k. So what is the meaning of n plus k? Where k is 0, 1, 2, that is n plus 0, n plus 1, n plus 2, and so on. That means this term will come after xn. So it will come obviously here, n plus k. So again here we have taken two terms of sequence which is coming after xn only. So the meaning is again same. So the main definition, the main concept of Cauchy sequence is uh, there will come a stage n. After that, all the terms xn's, all the xn's will lie close to each other. All the xn will lie close to each other. So that is called Cauchy sequence. I hope the idea is clear. Now we will move to the some important result, and we will also prove that result. Result is a Cauchy sequence is bounded, and converse, but converse is not true. Converse need not be true, right? So we will prove this statement. So let us prove. Now we have given a Cauchy sequence and we will prove that it is bounded. Let xn be a Cauchy sequence. Now if we revise the definition of boundedness, a sequence is said to be bounded if there exist two real numbers k1 and k2 such that all the terms of the sequence lie between this. Now how can I write all the sequence? I will write for all n belongs to natural number. Means all xn's, where n belongs to natural number, all xn's will lie between k1 and k2. This is the mathematical statement of boundedness. Now see, so I have to find out these two real numbers, right? So let us see how can we prove using the definition of Cauchy sequence. Now see, by definition 2, I am using the definition 2 here. For each given epsilon greater than 0, let epsilon greater than 0 be fixed. Epsilon greater than 0 be fixed. Then there exists a natural number n. I will write n because I have used n only in the second definition. So there exists a natural number n such that xn minus xn is less than epsilon for all n greater than equal to capital N. Right? Now what is the meaning of this statement? We can open the modulus and we will get xn minus, not xn, xn minus epsilon less than xn less than xn plus epsilon. Now see, this xn is fixed. It is a fixed term of sequence, and fixed term of sequence means some constant real number. This is also a fixed term, so this is again a constant real number. So xn minus epsilon is a fixed constant real number. This is also a real number, right? Please observe this and try to understand what I have written here. Please observe this. This is also a real number and this is also a real number. Because we have fixed, then there exists a natural number. This n is fixed, right? So xn minus xn is less than epsilon. So xn minus epsilon is a fixed real number. Xn plus epsilon is also a fixed real number. Now see, so after certain stage, now if I write x1, x2, so on up to xn minus 1, next term will be xn, and next term will be xn plus 1, and so on. So there are infinite number of terms, and for all n greater than equal to n. And this statement holds, this one holds for which terms? These terms, these infinite terms. Can you see? इन सभी infinite terms के लिए ये inequality hold करेगी. This inequality holds for these infinite terms, right? From xn onwards, xn के आगे वाली terms के लिए. So xn minus epsilon is less than xn is less than xn plus 1, xn plus epsilon means for all n greater than equal to capital N. तो ये जो terms हैं, ये कौन सी terms हैं? n greater than equal to capital, मतलब xn, xn plus 1, xn plus 2 and so on. ये कितनी टर्म्स हैं? ये इनफाइनाइट टर्म्स हैं. वो सारी इनफाइनाइट टर्म्स जो हैं वो इन दोनों रियल नंबर्स के बीच में लाई करेंगी. आई होप आपको ये क्लियर हो गया होगा कि हम यहाँ पे क्या लिख रहे हैं. अब ये एक आइडिया तो हमें हो गया कि इनफाइनाइट टर्म्स का हमने मैक्सिमम और मिनिमम वैल्यू निकाल ली है. हमें अब इन फाइनाइट टर्म्स के लिए भी निकालनी पड़ेगी. सो लेट k1 equals to minimum of xn minus epsilon. एक ये वाला लिया हमने, क्यों? क्योंकि ये मिनिमम है इनफाइनाइट नंबर ऑफ टर्म्स के लिए, और ये फाइनाइट टर्म्स है, इसको हम यहाँ पे लिख देते हैं x1, x2, so on xn minus 1. ये फाइनाइट टर्म्स हमने यहाँ पे लिख दी, क्योंकि फाइनाइट टर्म्स का मैक्सिमम मिनिमम निकालना पॉसिबल है. इनफाइनाइट टर्म्स का मैक्सिमम मिनिमम निकालना हमारे लिए पॉसिबल नहीं है. हमें नहीं पता कि कौन सी टर्म जो है इनफाइनाइट नंबर ऑफ टर्म्स हो तो हम उसमें से मैक्सिमम और मिनिमम कैसे ढूंढें. लेकिन अगर फाइनाइट नंबर ऑफ टर्म्स हैं देन वी कैन फाइंड. अगर 100 टर्म्स है तो उसमें हम देख सकते हैं कि कौन सी बड़ी है और कौन सी छोटी है. बट हमारा आसान क्यों हो गया? कोशी सीक्वेंस की डेफिनेशन का यूज करके हमारे लिए आसान हो गया कि इनफाइनाइट नंबर ऑफ टर्म्स का हम मिनिमा जो है वो निकाल सकते हैं. सो इनफाइनाइट नंबर ऑफ टर्म्स का मिनिमा ये है xn माइनस एप्सिलॉन. सो वो हमने लिख दिया और फाइनाइट टर्म्स लिख दी. तो ये क्या आ गया? दिस इज k1 इज अ मिनिमम फॉर ऑल टर्म्स. ये सभी टर्म्स का मिनिमम हो गया, राइट? सिमिलरली k2 हमने लिया मैक्सिमा किसका? xn प्लस एप्सिलॉन कॉमा, और ये फाइनाइट नंबर ऑफ टर्म्स हमने फिर से लिख दी. सो फाइनाइट नंबर ऑफ टर्म्स का मैक्सिमा भी हो गया k2, और xn प्लस एप्सिलॉन जो है वो मैक्सिमा है इनफाइनाइट नंबर ऑफ टर्म्स का. तो इसका जो सभी का जो मैक्सिमा होगा वो हमारे पूरे सीक्वेंस का मैक्सिमा बन जाएगा. सो दिस इंप्लाइज k1 लेस देन xn less than equal to xn less than equal to k2 for all n belongs to natural number, right? This implies xn is bounded sequence. ये bounded sequence की definition होगी. तो कोई भी जो कोशी सीक्वेंस होगा वो हमारा क्या होगा? बाउंडेड सीक्वेंस होगा, राइट? So this is a very important result, but converse is not true. Now we will prove the statement that converse is not true by taking a counter example. So converse of the statement is not true. Now what will be the converse? The statement is a Cauchy sequence is bounded. So its converse will be a bounded sequence is a Cauchy sequence. A bounded sequence is a Cauchy sequence. Now this is not true. Every bounded sequence cannot be a Cauchy sequence. Now we will take a counter example. Let xn equals to minus 1 raised to power n. Now this sequence is bounded, but we will prove that this sequence is not a Cauchy sequence. Now as we know, all the terms of this sequence lie between minus 1 and 1 for all n belongs to natural number. Therefore xn is bounded. xn is bounded. Now take difference of two terms, xn and xn plus 1. If I take difference of any two consecutive terms, fix the and first of all we will fix the epsilon. Fixed epsilon equals to 1 by 2, right? And take difference of any two consecutive natural number, and for any natural number n belongs to natural numbers, इन दोनों का डिफरेंस जो है वो देखते हैं क्या आएगा. माइनस एन minus 1 raised to power n plus 1, and this will be equal to 2 only. क्योंकि अगर ये ऑड होगा नेचुरल नंबर n तो ये नेगेटिव आ जाएगा, राइट, और ये माइनस, और अगला इवन होगा तो ये पॉजिटिव आ जाएगा. तो माइनस वन हो जाएगा 2, माइनस 2 का मॉड 2. अगर ये n इवन होगा उस केस में ये 1 बन जाएगा, और ये अगला ऑड होगा तो ये माइनस 1 बन जाएगा. तो उस केस में भी ये क्या आएगा, इसका सम 2. सो n कोई भी नेचुरल नंबर हो, इसका डिफरेंस जो है वो हमेशा 2 आएगा, विच इज नॉट लेस देन एप्सिलॉन, राइट, बिकॉज आवर एप्सिलॉन इज 1 by 2. If I take 1, then it also contradicts our result. So for as so we cannot find any n belongs to natural number such that xn minus xn is less than epsilon. For all n greater than equal to capital, right? So therefore xn is not a Cauchy sequence. So it is a very good example to prove that every bounded sequence is not a Cauchy sequence, right? So a very good example of minus 1 raised to power n. So I hope the idea is clear. Now I will post some other concepts, some other results related to Cauchy sequence in next video. Thank you.